Okay, so we're talking about domains and ranges, and we can end up in situations where we saw that our domain was not necessarily all real numbers, but we can have restricted domains too. And essentially, this is going to occur in two cases for us that we're going to look at. Case one is any situation where we have a, how do I want to write this? Just say f of x equals something in the numerator. I'll just put numerator here. Doesn't matter what's in the numerator. Divided by 0. Whenever that happens, this does not exist. This is an indeterminate. So whenever you have a function where there ends up being a 0 in the bottom, that's going to cause us problems. Or anytime we have a function where we have a root and the argument inside is less than 0, because that'll give us a negative root, and we can't deal with negative roots. For example, square root of -1 equals, well, of course we can deal with it, as an imaginary number, but there are no real roots to this. And right now, when we're talking domains in the real number system, real values of x. So these are two problems that could occur in functions. For example, we could have f of x equals 1 over x minus 2. So what's the domain of this? Well, this is case number 1. We're going to have a problem if the denominator ever goes to 0. So let's examine this. So if we have positive numbers, well, let's go with negative numbers first. If we have negative numbers, let's say -2, then f of x is -2 minus 2 equals -4. That's okay, that works. -1, we have -1 minus 2 equals -3. That works. Pretty much any negative number up to infinity we stick in here. It's just adding a bigger negative number to -2, and it's going to work. So that left side works. So then next, let's check 0. This is going to be 0 minus 2 equals -2. Well, that works. That gives us an answer, a single answer. So far, from the left, -infinity to 0, this thing behaves like a function. Y is a function of x, or f of x. So let's go positive now. If we put in 1, we have 1 minus 2, and 1 minus 2 is -1. Well, that's okay. That works. But now when we hit 2, look what happens. We have 2 minus 2 equals 0, and 1 over 0 we can't do that. So this is a problem. This problem persists. If we go past 2, so we have 3 minus 2 equals 1. Actually, this is an f of x x. This is really just the denominator. We're not worried about the numerator, it's always 1. So anyways, 3 minus 1 is 1. Well, this is okay. And in fact, if we any other value of x we stick in here greater than 3, it will be fine. We'll be able to calculate that. It might start getting, f of x might start getting really, really small, but we can still calculate it. So we would say here that the domain is all real numbers but 2. Or I could be more specific and I could say x equals 2. But a simpler way to write this would be x is not allowed to be equal to 2. So I'm writing the opposite. X is not allowed to be equal to 2. Another way to write this is we could write minus infinity to 2 and 2 to infinity. And there's a couple other ways to probably write this. This is probably the easiest way to write this situation though. X is not allowed to be equal to 2. Okay, so that's our case 1 problem when it occurs. So let's look at the other situation. So you have f of x equals square root of x minus 3 over 6. Well, we're not going to ever have problems with the denominator here, but now in the numerator I have a root, and there's some places where this root is going to give us an imaginary number, and that means that we won't have those numbers in our domain. So let's see. When do we have an imaginary number here? So when does numerator go imaginary? That's going to be a problem. We're going to have to exclude that from our domain. When does it go imaginary? It goes imaginary when the argument of the radical is less than 0. Not equal to 0. We're allowed to be equal to 0, but it's less than 0. So let's figure out where that happens. Where does that happen? Well, that happens, the crossover point occurs when x minus 3 equals 0, or when x equals 3. So when x equals 3, this equals 0. We're allowed to do the square root of 0. But now what happens if x gets bigger than 3, even an infinitesimally small amount bigger than 3, like 3.001 minus 3, we're going to have a negative 0.0001, the square root of that, which is going to be an imaginary number. So our domain then is x must be less than or equal to 3. We're allowed to be equal to 3, so we have to include that. Another way to write that might be minus infinity to 3, and then we put a rectangular type bracket here to say that that includes 3. Another way is minus infinity is less than x is less than or equal to 3. A couple different ways to write that. So that's how we handle those situations. Now we could have a combined situation, and I'll I'll challenge you to do this on your own. So you have f of x equals 1 over the square root of 2 minus x. Now we got a double problem down here in the denominator. Anytime x equals 2 is going to be an issue, right? X equals 2 is bad for us. But we also have anytime x is greater than 2, that's also bad. Why is it bad? Well, because now we're going to end up with a negative number in here. So our domain here, we have to take both of these ideas into consideration. And we could just say x must be less than 2. Not including 2, but less than 2. You know, we can write it a couple different ways like we did over here. I suppose I'll do that. We could go minus infinity and 2, soft bracket. Minus infinity is less than x is less than 2. So in summary here, the domain is all allowed x values, and the range just simply is all y values you can get given an x value in your function.